Rational exponents. What does that mean again? What's it mean? What's rational mean? Ratio, which means a fraction. So like x to the 2/3 power, right? How can I rewrite that in radical form? What do I mean by radical? Good guess. This is a radical. I know a lot of you call that a square root sign. It's actually called a radical. Okay? Now I think we call it a square root sign because that's what we use it for most often. Okay? But today we're going to talk about other kinds of roots, and we're going to have to use a radical. Does that make sense? So how can I rewrite this rational exponent in radical form? Do you remember on our foldable, if I have a fraction, what does the top stand for? That's the power. What's the denominator stand for? The root, right? So what kind of root am I taking here? The cube root, right? A third root. So I have to actually use a radical, but I have to put a little baby 3 up there. Now, do we normally call it a little baby 3? No, we call it a cube root, right? I just want to make sure you understand. I'm purposely writing this 3 smaller, and it's sitting on the little ledge right there, right? Okay. Now, what goes on the inside of this cube root? X squared, right? X squared. Does that make sense? So a rational exponent is a exponent that is a fraction. A radical is this sign. It could be a square root, it could be a cube root, it could be a 4th root, it could be a 12th root, right? Now for the record, we won't be doing any 12th roots. Okay, today we're going to do square roots, cube roots, and 4th roots, but we could do 5ths easily enough. Okay, but if this is a square root, why don't I put a little baby 2 right there? Because why? Kind of. Like, if I'm talking about this variable right here, what is the coefficient on this variable? 1. How come I don't write a 1 right here? It's understood, right? What's the exponent on this variable right here? A 1, right? How come I don't write it? It's understood. So why wouldn't I write a 2 on the outside of the square root? It's understood, right? That's the one we use it for most often, so I don't have to write a 2 out there. Could I if I wanted to? Yeah, but we just don't, right? We don't because it's understood. Does that make sense? Okay, so let's talk real quick about something like, first of all, we already talked about x to the 2/3, and we remembered from our foldable that we made the other day that that's the same as the cube root of x squared, right? Well, what about xy raised to the 3/4 power? What's being raised to the 3/4 power? X and y, right? So I could distribute this into each exponent and say x to the 3/4, y to the 3/4, right? Or I could go straight to radical form, depending on what I'm asked for. If I've asked for exponential form, I need to distribute that inside, don't I? If I'm asked for radical form, what I need to take is what kind of root? The 4th root of xy to the 3rd. Now, even though it's in radical form, I still want it all the way simplified, don't I? Tell me what's being raised to the 3rd power. X and y, right? So the 4th root of x cubed, y cubed. Any questions about that? What if I ask for this, x to the 4/3, in radical form? So a cube root of x to the 4th. So here's what's going to happen. I'm going to have to stop right here because there's another step we can go, but you're not ready for it. You'll be ready in a couple minutes, but you're not ready for it quite yet. but I needed to make sure you understood what it meant first, and then we'll solve some other stuff, and then we'll come back here. Are you okay with that? Okay. So I'm going to draw a line to remind myself to come back to that one. Okay? So let's start here. Let's talk about simplifying radicals. We already talked a little bit about simplifying rational exponents, right, into radicals. But let's talk about simplifying radicals themselves. What about this? What's the square root of 9? 3. Okay, we'll fight about that later, right? But right now, I'm going to say 3 is fine. Okay? What about the square root of 36? Try one more time. Yep, 6. Okay. What about the square root of 24? Yeah, that's the face I expected, right? If it was 25, that would be super easy. It would be 5, right? But when they ask for the square root of 24, there's not one, right? But I'm not asking for an exact number. I definitely don't want a decimal. I want a simplified radical. Okay? So here's what I need you to do. I need you to think about, do I know any numbers that divide into 24 that I know the square root of? 4, right? 4 for sure. Now, I don't want to choose 3 and 8 because I know 3 and 8 multiply together to be 24, right? But do I know the square root of 3 or the square root of 8? No, I purposely want to choose 4 and 6, okay? Because the laws of radicals say that I can break this into 2 parts, 4 times 6. Again, I'm choosing 4 and 6 on purpose because I know the square root of 4. But here's where the laws of radicals actually come into play to help us out, because they say I can even break this down even further, like this. Well, do I know the square root of 4? It's 2, right? Do I know the square root of 6? No, I don't. I leave it. So the square root of 24 is actually 2 root 6. Does that make sense? What about the square root of 27? Do I know the square root of 27? No, so I have to think about numbers that divide in evenly into 27 that I do know the square root of. 9, right? 9 and 3. So I can break it into 2 parts, 9 times 3. Remember, laws of radicals say I can break this even into 2 more parts, the square root of 9 times the square root of 3. Well, what is the square root of 9? 3. And what's the square root of 3? I don't know either. So we leave it alone. What if I ask you for something like the square root of 52? Do you know the square root of 52? Well, we know the square root of 49, so we probably don't know the square root of 52, right? It's something we would have to break down like this. I already told you ahead of time I don't want decimals. I want a simplified radical, right? But I also know enough. I have to decide, is it working smarter to sit here and think to myself, okay, 52, what multiplies with 52? I know 2 and something, right, because it's even. Or is it smarter for me to let the technology help me? If the technology is helping me, what am I pressing into my calculator? 52 divided by what? Do I care about 2? No, because I don't know the square root of 2. What do I care about? 1? Well, not even 1, because that's not going to help me, right? What else do I know? Or what else do I care about? 4, 9, 16, 25. Why do I care about those numbers? Because I know the square root of it, right? So I'm doing it in my calculator. I'm saying 52 divided by 4. See if it works. 52 divided by 9. 52 divided by 16. Now it happens that 52 divided by 4 works. It's 4 and 13. So I could go from there, right? But using my calculator doesn't always mean I don't know my facts, right? Using my calculator sometimes means I don't want to waste time trying to process this with my brain when I could use the time better doing more examples. Does that make sense? Or doing more homework problems or something like that. Yes? Any questions about that? Then what about the square root of x squared? What is the square root of x squared? X. Okay? Think about this for a second. Going back to our rational exponents that we talked about the other day. What does the square root mean? What exponent would I use for square root?
Power root.
So 1 over 2, right? So isn't this the same thing? X squared to the 1/2 power, isn't that the same as the square root of x squared? What do I do with a power raised to a power? What does my exponent foldable say I'm supposed to do? Did I eat my exponent foldables for a snack? Oh no, there it is. What do I do with the power to a power? Multiply, right? I multiply. So what is 2 times 1/2? 2 over 2, which is what?
2.
Just 1. So no matter how I write it, I still get x as my answer, right? But if I think about it, I get x to the 2 over 2, like you said. That's something that can be simplified, right? If it can be simplified, it can be pulled out of the radical, can't it? So think about this. The square root of x to the 3rd. There's 2 ways we can think about this, right? First way we can think about it is the way we thought about these numbers. And I can say x squared times x, right? Well, what did we just decide the square root of x squared was? X. Do I know the square root of x? I don't, so I leave it inside the radical, right? But I could also think about it like this. X to the 3rd power raised to the 1/2 power, right? So x to the 3/2 power. Isn't that the same thing? Well, if it's x to the 3/2 power, I could break that into x to the 2/2 power times x to the 1/2 power, can't I? Why would I break it into 2/2? That's something I can simplify, right? And if it simplifies, it can come out of the root, can't it? Well, what is x to the 2 over 2? Just x, right? And this stays x to the 1/2, but remember what's the same as x to the 1/2? The square root of x, right? So isn't this the same answer as x squared of x? Aren't those two the same answers? We just went about it 2 different ways. Why am I showing you 2 different ways? So you can pick which one makes sense to you, right? Is there always only one way to do things?
No.
No, hardly ever. I want to show you both ways that I know so you can pick which way works best for your brain. Okay? So do this one for me. Square root of x to the 7th. Do you want me to do it both ways still? While we're still thinking about it? Still learning? Okay. If we're doing it both ways, the first way I want to choose is x to the 6th times x. Why would I choose x to the 6th? Because I know the square root of it. What is the square root of x to the 6th? X to the 3rd. Yeah, absolutely. Right? Because remember, if that's the same as the 1/2, we'll get there in a second, but I'm just pulling out an x to the 3rd, but I don't know the square root of x, so I just get square root of x. Okay?
Can you also do 3 and 4?
Oh, I don't want to do 3 and 4. Right? That's a good question. I don't want to do 3 and 4, because while I do know x to the square root of x to the 4th, I still know something inside x to the 3rd, don't I?
Yes.
Okay? That's a good question, though. Let's do this the other way. This is x to the 7th to the 1/2, which would make it x to the 7/2, right? And how would I break this down? X to the 6/2 times x to the 1/2. 6/2 can be simplified. What does it simplify into?
33.
X to the 3rd. X to the 1/2 is the same as square root of x. First of all, can you tell that they're 2 different ways, but they get you to the same answer?
Good.
Have you decided which way you like better yet?
The first one.
No, you don't have to tell me, right? It's not my decision, it's yours. It was mostly a rhetorical question, but thank you for answering.
Sorry.
You're fine. What about this? What if I ask you to do more than one thing at a time? Can you? 8x squared y. Square root of 8x squared y. Well, do we know the square root of 8? Oh, we do?
No.
Oh, wait, we don't, right? We know parts. It would be 4 times 2. What's the square root of 4? 2. What do I do with the 2? I leave it underneath, right? What's the square root of x squared? X. What's the square root of y? I don't know either. That's just my answer. Okay? What about the square root of 16 x to the third y to the fifth? Do I know the square root of 16? What is it? 4. Do I know the square root of x to the third? No, but it's x squared times x, right? Do I know the square root of x squared? It is. What do I do with this other x? Leave it underneath. What about y to the fifth? Do I know the square root of that? I know y to the fourth times y, right? Do I know what is the square root of y to the fourth? Y squared. Very good. And what do I do with this y? Leave it underneath. So now I got to throw you off balance just a little bit. Just very, very slightly. Okay? I'm not going to push you. Not on camera. What's a cube root of 8? Well, what does the square root mean actually? What times itself is that number, right? If a square root is what times itself equals that number, what does a cube root mean? What times itself times itself, right? There has to be 3 times that you multiply something by to be able to pull it out. Do I know the cube root of 8? It is. It is 2. Do I know the cube root of 16? No, but I can do the same thing I did with square roots. I know the cube root of 8, and that's 8 times 2, right? So what is the cube root of 8? 2. And what do I do with this other 2? I leave it underneath, right? So what about the cube root of x cubed? What's that? X. And what's the cube root of x to the fifth? I could either say x cubed times x squared, and I know the cube root of x squared is x. And what do I do with this? Leave it alone, right? Leave it underneath. Or I could say x to the 5/3. That's the same as that, right? And I could break that into x to the 3/3 times x to the 2/3. 3/3 is 1, so that's x. And x to the 2/3 is the same as, well, it would help if I wrote this right. Can I fix this one real quick? What should this be? This should be a 2, because that's what was left, and this has to be a baby 3 up here. Is that what you were trying to tell me? Okay, thank you. What is x to the 2/3 the same as? The power and the root, right? The cube root of x squared. Now, can we please go back to that very first example that I was talking about right over here? X to the 4/3 equals, now we rewrote it in radical form, but is this all the way simplified now? It's not, because if it's 4/3, that's the same as x to the 3/3 times x to the 1/3, right? And what is x to the 3/3? That's just x, and x to the 1/3, power and root, is just the cube root of x. You see why I didn't do that first? Does it make more sense now? Okay. Now, we've done square roots and cube roots. What's left for us to do? Fourth root, okay? So what is the fourth root of x to the fourth? What does a fourth root mean? Right? 4 of them. So what is the cube root? The fourth root of x to the fourth? X, right? Because I could rewrite it as x to the 4/4, that being the power and that being the root, and 4/4 is 1, right? I don't. I put it in her notebook.
Okay, so it's
Yes, sir. Thank you. Which is x to the 1, which is just x, right? It's just the same thing we got up there, yes? So what about the fourth root of x to the 5th? So x to the 4th times x. And we know the fourth root of x to the 4th is x. And do I know the fourth root of x? No, so I leave it alone. Can I give you a really super hard one?
Sure.
What is the fourth root of x to the 19th? I said, what is the fourth root of x to the 19th? Is it really hard? No, because this is really what? X to the 16th times x to the 3rd? What's the fourth root of x to the 16th? X to the 4th? Do I know the fourth root of x to the 3rd? No, so leave it alone. Any questions?